Okay. 9.3 is literally a slide. This is putting it together. What do you use when? Slide 91, I'm gonna pull that up, but just so you know where it is. If you go to the PowerPoints, can I just zoom this in? So if we have a z-test and a t-test. So you don't know which one to use. Basically, you come here, okay, what are we estimating? Are we estimating a proportion, a mean, or a standard deviation? Okay, for proportion, so our p-value. Hey, they're going to tell us how to do that. If it's a mean, we have a little more information. So you just follow the flow chart. A lot of times we're going to come to the t-interval and use that. So that was the one we just did last section. And then standard deviation, we don't know how to do that yet. So we're going to see this same chart later when we deal with other methods, just to see which direction you go. So I would recommend at some point, once we get all of our tests, make a, hey, use this test for these things, use this test, just to make a chart for yourself. Okay. That is literally all of 9.3. I'm not going to write down more than that. 9.4 is our last bit, and we have a weird little activity for it. And this is called estimating with bootstrapping. I don't know why it's called bootstrapping, but we're going to go with it. So what this is we use a computer and sample data create a new data set. So we're going to create a new sample set is really what we do. We're going to take random data values with replacement. To create a sample size n. So according to the book, we're going to, if our original sample was size n, our new sample should also be size n. And we're going to go through one of these because it's a weird idea. So we're going to hopefully make it make sense. I find that they're pretty not terrible. So the center of your bootstrap distribution must be close to the center of the sample data. Oof, there we go. And close is kind of relative. If you find your mean of your sample data, the center, the median, the middle is 10, and the middle of your new sample data is 20, that's probably not close if your numbers are all really small. If your numbers are really big, 10 and 20 aren't terrible. Like that's not a lot apart. So it just kind of depends on your data. That's a lot of statistics, unfortunately. It depends. And a second one, it needs to be symmetric. So if your original data is symmetric, and ideally it is, your bootstrap should also be symmetric. So take your middle, the same number of data values on the left as the right. They give us an algorithm, but it's really not an algorithm. So things to note, we'll say. Bootstrap. The size of your new sample should be the same as the size of your old sample. So if we had 20 data values, your new one should also have 20. It may not look the same because you could draw the same number a couple times. Determine what you're looking at. Do you need mean, standard deviation, proportion? That'll usually be pretty clear because they'll tell you. And then you should always check your middle, lower, and upper bound. Those should be fairly close to your original data. So we want to make sure, say we're looking at the middle 95%. Our data values should be close to, let's say if we're using means equals, no, not equals, wow, plus or minus T alpha over 2 S. So we would use our alpha equals 0.05 and our N of whatever it is and use the table 7, like we did last section that we really talked about, and use that N value to get your alpha over 2, your T alpha over 2. Okay. I'm going to show this a little bit, and then I'm going to have everybody do this as well. Oh, keep doing that. So where I'm going to go is I have my StatHacks data set. This is pulled from the book, the slides, nothing magical. These were means. So those are our data values. And I put them in order. You don't necessarily have to, but I chose to. And then I numbered them. So our first column is the position of our data, like first, second, third. The second column is the actual data value. And let's say I want a data set of 3 data values. We have to choose at random. So there's computer programs that'll do this for us, but we're going to do it by hand. So I have 20 data values. Is anyone familiar with a 20-sided dice? 20-sided die. Oh, fun. You get to find out today. Oh, wrong thing. A 20-sided die looks like that. So there are 20 sides to it, and they each have a number 1 through 20. I linked this on announcements so you can actually find this and see it. So I was going to bring in actual dice, but I forgot. So we're going to use the simulator. Let's say we roll. Okay, 7. I'm going to take the data value in the 7th position. Okay, going to roll again. 9. Okay, my next one, data value in the 9th position. Let's get 5 of these before I can do this. 6. 6 again. So remember, we're doing with replacement. So if the same number comes up twice, that's okay. 3. Okay. So we're going to take the 7th, 9th, 6th data value twice, and the 3rd data value. I'm going to come over here. My 7th data value was 27. My 9th is 27.2. My 6th one is 26.4. And then my 3rd data value is 25.9. So all I did was roll my die and then match it up to the position of this. If you have a bigger data set, you can't use a 20-sided die. You'd probably have to use something like, I told ChatGPT, hey, give me 20 rolls of a D20. And so they gave me 20 numbers. So those are the positions we would use. But I'm not going to worry about that at the moment. Okay. So my data values were 27. Oh no, these are just my X, not my mean. 27.2, 26.4, 26.4, and 25.9. So that's our new data set. Really it should have 20, but we're going to make that work just fine. All right, so now I'm going to take the mean of these. So 27 plus 27.2 plus 26.4 times 2 plus 25.9. So my sum is 132.9 over 5. I get 26.58. Now, if we were going to do the whole thing, we would say, okay, find our new mean. How does that match with our old one? Is it close? And then you would find the middle 95. Let's see, our n is 5. So our degrees of freedom are 4. And my T alpha over 2 corresponds to T.025. So, I didn't give a standard deviation. At this point, we would take our table. All right, degrees of freedom was 4, so we would come to that level there. T alpha over 2. It's going to be this middle column. So our T value we would use is 2.776. And we would do the same thing we did for the other sections. I don't have a standard deviation, so we're not going to worry about that part. Okay. So what I'm going to have you do is get the data set I pulled up. You have a link to it, and I'll double check. And you're going to get your own bootstrap sample, and then we're going to compare. So I'm going to stop my video because people don't care about watching this part. So bye.